Today, we learn about limit state of collapse, compression, point-wise from IS456-2000. In my last video, I talk about the limit state of collapsibility. In case you missed it, so go and check out my last video from I button or go to playlist. Okay, so without further delay, let's get started. Hope this session will be great for you. Hope this session will be good for you. So as per limit state of collapse, there must be few assumptions. So first we talk about assumptions. Okay, before starting the assumption, this clause number is 39 and last clause, that is our collapsibility, that is the clause number 38. So previous all assumptions are applicable. Further, we added the two assumptions. Okay, number one, the maximum compressive strain in concrete in axial compression, not maximum compression, axial compression. Many students have do some mistakes in their axial compression, total compression. So axial compression is 0.002. Number one. Number two is saying that the maximum compressive strain in the highly compressive extreme fiber concrete subjected axial compression and bending when there is no tension on the section shall be this minus 0.75 times of strain at the least compressed extreme fiber. So that they are saying that 0.0035 minus 0.7 times of least compressive, least strain, E concrete least. When this is applicable, now the maximum compressive strain is highly compressed extreme fiber in concrete subjected to axial compression and bending but no tension. In that particular scenario, you can use this. Okay. Now we talk about the minimum eccentricity. So as I said, previous assumption also be taken, and there's many too. So once I just repeat the previous assumptions once more. Number one assumption was remain plane after bending. This is the first. Concrete maximum compressive 0.035. Okay. Shape is mostly parabolic, but there's many more shape, but we consider this shape. Then we talk about the concrete tensile strength, we ignore. Gamma steel is 1.15, maximum steel value this. Okay, so this is the assumptions for your steel, I mean to say collapsibility, and for compression limit state you these two, I mean these 6 and again these 2, total 8 assumptions. So now it is clear what is the 8 assumptions for the limit state of compression. Okay, what is eccentricity? Say this is your axis, but load is applied this. So this is your eccentricity. So what is the minimum eccentricity? All member in compression shall be designed for the minimum eccentricity, that is the L by 500 D by, this is the value, that is the formula. Where calculated eccentricity is larger, minimum eccentricity should be ignored. Either 20 mm, L by something, D by something, you remember? That is the thing. Now we talk about the short axially loaded member in compression. When we talk about column strut, then we introduce this thing. So for as the column is your compressive member, so we will talk here short. So short axially loaded member in compression. That is equal to PU equal to 0.4 FCK plus AC plus 0.67 FYAS. That AC means cross-sectional area for concrete. That is the cross-sectional area of steel. 0.67 FY means design strength of steel. 0.4 FCK it means design strength of concrete. FCK must be 20, 25, 15. FY must be 250, 415, 500. Maybe higher than this. There's a helical, you may or may not be, but I will not cover here. And then I talk about so basically these two are the most important from our IS code. There are many more, that is the compression member, helical reinforcement, combined axial, then slender compression member, then uniaxial bending combined. So you may or may not be, there's no mandatory things, but these two are very much important understanding the RCC. So this is a very short and simple video. Here I stop this video. If you have any doubt, do comment in the comments and I definitely get back to you. And if you find some value from this video, then spread this knowledge to your community, because more knowledge, more safer side. So hope you understand. Till then, bye bye. See you in next video.